What's up guys, my name is Mike, I am a software engineer, algorithmic forex trader, and recently I live in Thailand as an expat. For those who are new to this channel, if you are interested in algo trading, feel free to subscribe to this channel and join our Discord group to exchange any interesting ideas regarding forex trading, market trading, algo trading, stuff like this. And now let's move to the main topic of this video, which is me sharing my journey on building proper software for latency arbitrage algo trading. So let's see when we stopped last time. In the previous video, we checked the application called FXbox. We designed the user controls and the logic. The app completed the goal as it produced successful trades which exploited latencies between different brokers. However, the app had major design issues due to which it was not scalable at all and needed refactor or even recode. Okay guys, so this one will be long and more complex, just letting you know before. So I checked the news and decided to do entire recode of my app to the .NET 5 from .NET Framework 4.7. So .NET 5 was cross-platform, so the change was mandatory also because I switched to macOS, which is actually a Debian-based system, so it's not Windows. And because of that, we needed cross-platform. Just didn't want to ditch Windows because most of the VPSs and servers are still based in Windows when it comes to HFT trading. So when I choose the platform, I needed to find a good cross-platform library to handle the user controls. So I was thinking at some point to use Blazor with Electron, but the Electron performance is rubbish. Microsoft Teams are based in Electron, for example, and the performance of them is really rubbish. If you ever use Microsoft Teams, you know what I'm talking about. So after some time of research, I have found the Avalonia framework. So the Avalonia, it was kind of a new and it was similar to WPF on Windows. All the windows and controls were designed in XAML files with MVVM pattern, so model view view model, if you're familiar with that approach. And the most important thing, I could compile this on macOS and Windows, which made me able to do all of my development on macOS and export final version to Windows to deploy it on my VPSs. So the solution was perfect. So the next thing was to fix the issues with the design. And at that time I was learning clean architecture concepts and also CQRS, so I gave it a try but modified it a little bit to fit my needs. Let me go outside. So when it comes to the front end for data display and user interactions, I had to plan decently because last time I messed up big. So in order to do not fail this time, I needed an example of something that is working and I can use it as a template. For that reference, I took the MetaTrader platform. So when you open the MetaTrader 4 platform, you have on the left the control with streaming quotes, you have the control for open trades on the bottom, and also you have the history trades and logs and many more options on the bottom tab bar. You have also the main dynamic tab bar in the center of the app, which is responsible for displaying the chart data. I think it is a good design as it is used in most popular trading apps. My app was not a MetaTrader. It had more functions like being able to connect to multiple accounts at the same time. So in order to find good match for me, I needed a second example, and I used for that one the IDE application I was developing at that time, which was Rider from the JetBrains company. So what I noticed is that the layout of Rider was very flexible. They had the static tab bar on each side of the app, top, bottom, left and right. They also had a dynamic tab bar in the center of the app to display the dynamic content. You could add tabs, remove tabs based on your needs. That was perfect. So I added on the left the broker's connections control. I named it session control. I added algo strategy control on the same side also. On the right side, I put the control for live quote data display. I would display all the live quotes from all the connection sessions. On the bottom, I would add the tabs for opened trades, closed trades, and the logs, same like in MetaTrader 4 or MetaTrader 5. And also on the top tab, I wanted to add some general settings information like in Rider or MetaTrader. I like the design of the Rider that much that I also tried to mimic the dark Dracula color theme I also using in the Rider. But I couldn't find any good templates for Avalonia, so I had to just pick the colors by the RGB and just create the template by my own. The design of front end was done, so then I had to design all the backend logic and structure the project reference tree. Okay, so this is one of the diagrams I made. So as you can see, we have different blocks like user interface, FXbox action, state, event dispatcher, command dispatcher, and session service. And session service was responsible for accessing session objects. By session, I mean the connection to the exchange or broker. And those objects actually communicate with the broker. The FXbox state was responsible for keeping, it's like a repository to hold the current state of all the objects, all the connections, all the trades, and all the tickers. And FXbox action is just a module to handle the user events. So if you click on a button, it goes through the FXbox action module. Event dispatcher, command dispatcher, it's something like trafficker. I don't know if you're familiar with this service, but basically this is something like a middleman that takes the events and segregates the events by the type and invokes current handlers that are responsible for doing the action for the events. So anyway, let's move forward. Here you can see what I made at that time was just a simple description of the domain objects. So we got the FXbox session, the trade abstraction, session abstraction, and symbol abstraction. So if what we can see here, this interface IDTO, then iSession DTO, basically this is like an inheritance tree. So it describes what kind of objects inherits from what objects. So basically, as you can see, we have the session, we have the trade, and the main objects inherits data from the observable object. So basically, this is the purpose of this is to invoke the refresh handlers on our dashboard on GUI. And here, let's say I trade, we inherit from IDTO, then trade 1 DTO, trade DTO, and basically the lowest level of the abstraction of the inheritance is just the IDTO, which defines the data transfer object. So from what I can remember, I think I included their ID for each DTO. Anyway, let's move forward. Another slide, another diagram that I made was session communication flow. And on the left side, you can see all the event names, and the session comments. I think this was also an event. So just to give you an example, here, let's say we are invoking session connect command. So what happened next? We send request to the exchange server, broker server, for a connection, and then we receive response. We receive either success or fail. And when we receive response, we invoke dedicated event. In case success, we invoke session connected. In case of failed, we invoke session connect failed. And then we can bind our handlers to those events that will actually do the action that we want our software to do. So I made that kind of events for connection, disconnection, subscription, unsubscription of the tickers, open trade, close trade, stuff like this. So it was pure event-based system. And now if we go to the main diagram, the core that describes the core of the app. So on the top, what you can see, these are the projects, the libraries that I splitted the FXbox solution. So here we can see the terminal, FXbox core, CQRS, session 1, session 2, and on the right side in blue, you have actually everything what happens in the exchange server, broker server. So just to give you a small example, let's say we receive new quote from the server. So what happens? Here we have on the right the broker server 1. And if you see on the arrow, you can see new quote. So what happens? We receive new quote from the broker server, then it goes to the FXbox session 1. You can replace the one number with MetaTrader 4, for example. So we receive to our MetaTrader 4 object new tick, new quote. So what happens then? It goes here, create session event. So from the MetaTrader 4 session object, it goes to the common service to handle all of the sessions. So it creates session event, in our case, new quote event, and goes to the session service. Then session service forward that events to our event dispatcher, and event dispatcher recognize the type of this event. Either it's a new quote or session connected or trade open. In our case, new quote, and it invokes correct event handlers to handle the new quote data. So then it goes in the FXbox core, and then the event handler module invokes all the handlers, which are in that particular case updating the state of our objects, of our domain objects. And when the state is updated, it passes the information to the user interface, user GUI, and actually you can see the new quote prices, new prices on your dashboard. So right now let's go also with the trade logic. So let's say you want to open a trade. So you click on user interface, and the user interface, you click on a button, and this one invokes the specified command that goes to FXbox action. FXbox action creates command object, so it's something like an event object, and passes it to the command dispatcher, which is in FXbox Secure S. And what happens then? Command dispatcher recognizes that kind of command and passes it to the correct service. In our case, it passes it to the session service. Session service forwards command to the correct session, let's say session 2. Let's say session 2 is session MetaTrader 5 or session fix protocol. And then session object takes that information and sends request to the exchange, to the broker server. Broker server sends the response of either that trade was filled successfully or it was rejected. And then one more time, the information from the broker server goes straight to the session service by creating session event. Then it's being forwarded to event dispatcher, event handlers, and then in FXbox state, you can see if the trade was successfully, so you will see new trade in the trade repository, or trade failed, so you will see the information in logs. And then after status updated, it forwards that information to user interface, and you can see the result on your dashboard. So that was the diagram. Let's see maybe now the code, the project structure, and the actual application. Developing this thing took me a lot of time, at a lot of try and error, but I was pushing forward, and at some point this application started to actually work. I was hooked on that, so I started to add many new connections. I even included the live feed of quote data straight from LMAX Exchange's website. So it was not as fast as the original .NET LMAX API or the Fix API they have, but still, with help of one of my friends, we managed to do this. So I was also playing around with different strategies, and the most important one strategy for making all of the benchmark performance tests was, of course, the most simple one, which is one leg latency arbitrage strategy. If you are watching this video, I assume you already know how one leg latency arbitrage strategy works. So just open the trades on price gaps made by latency issues of different exchanges or brokers and close them on a gap fill. Simple as that. So now it's finally the time to show you the actual app. Okay, so this is the app. Let me try to connect to one of those connections just to show you how it works and how the quotes are changing. So let me try with that one that is not disclosed. Let me turn it on. As you can see, logs are being produced. And okay, we have the BTC with ask and bid, spread, timestamp, and everything is changing. And if I double click or click on manual trading, you can see that I have a window, like a small window, small terminal to put the quotes. I got lot size. So let me open a trade. And yeah, as you can see, the trade was executed in here. And let me close this trade. And the trade was closed. If we go in here, we have all the information like session, the type by market, volume, open price, slippage, open millisecond execution. Yeah, so it looks like this. So pretty much it's a fully versioned trading terminal. So we have also strategies that we can start, stop, and if I go here, show details, you can see we can have multiple tabs in here. So yeah, this is it. So this is the terminal. I was very proud of it, but let's move forward with the content. So let me just stop this one. Just stop, disconnect, and as you can see, the quote stopped to stream. So the form of the GUI is very nice, but in future I would like to do something similar when it comes to front end, but with totally different back engine. But yeah, more about this in future. But did this version of FXbox solve all of my previous issues? When it comes to the GUI issue, definitely yes, it solved my issues. Finally, I had a nice template of user interface that I can pretty much easily expand and add new features that will be organized. Just add more dynamic tabs to be displayed in the center of the app, and add more static tabs related to new features on the left or right or bottom or top bar that will represent the main controls of the features. That problem was definitely solved by the power of referencing the already working solutions, like creating my designs based on actual working solutions. The problem with missing quotes due to thread spin was also solved, as I created one pipeline to handle all the live ticks from all the streaming quotes from all the connected sessions. On the end of this pipeline, I had a function to loop all the strategies and loop all functions of the affected ones. So how about the issue related to scaling up the opened connections and running strategies to be able to run, let's say, 100 strategies on 100 connections? The problem got more defined, I would say, but unfortunately it was not solved. So let's have a look what happens in the app when the new tick data is received. So we get the new market data. The market data is getting deserialized and put into the common tick event argument object. And the new market data event is being triggered when new market data argument arrives. And now, pay attention. When you invoke event in C#, the code is being executed on the main thread. Also, the execution is not being done async. What I mean by that is when you have, for example, 3 new market data messages, we invoke first message. The event is processing all the code of all binded handlers, and when the code executed fully, then the runtime invokes the second market data, process all the handlers, and goes to the third one. And what happened if the execution of some handlers will get stuck for 1 second, for example, due to some sending trade information issues? All the other market data invokes will get delayed by that 1 second. So there is a huge issue with the delays. Another thing is that one of the market data handlers that has been binded was a function to refresh the GUI with new market data information. In theory, it looks okay because we got new data, we just want to display this data on the GUI, display the update that we have, but that is perfectly fine approach, but no for a low latency trading system where you can have huge volume of market data coming to you during 1 millisecond. And this is also not necessary. The standard monitor refresh rate is, I think, 60 or 120 FPS frame per second. And with 120 FPS, you get one refresh every 8.3 millisecond. So there's no point to refreshing your GUI every 1 millisecond, as your monitor can handle only one refresh every 8 milliseconds. So yeah, that's pointless. So just to give you an example, the very good low systems with good market data injections can handle about 100 quote tick data updates per 1 millisecond. So now imagine the market data invoke function being triggered 100 times per 1 millisecond, and during each invoke the user interface should get refreshed for user view. That's madness. That's crazy. There's no point to going with this approach. So this is just not gonna work with those speeds. Also, another issue was the sending order part. The exchange connections were processing order requests, not async. They were sending order and waiting for response from the server. So now again, when we have 1 millisecond processing time for opening a trade on the exchange side, it means the pipe that provides refresh market data ticks will get stacked for 100 milliseconds because of some strategy decided to open a trade. So it shouldn't be like this. And also, I was building a class objects during the hot path of getting new market data and sending the order from algo strategy, which is also not a good approach. Another thing is that I should not touch the heap memory while allocating new parts of memory to some trading data. So the performance was still a big issue with the FX box application, but we were getting closer and closer to the final product. So I had to make a big research on how other companies develop proper low latency trading systems and implement their designs to my app, as this approach worked with the front-end user controls issue. But more about this in the new video. So guys, thank you for watching this episode of me building a trading software for low latency, high frequency trading with focus on latency arbitrage trading. If you like this type of content, please subscribe to this channel. It helps me a lot to get motivated to produce more YouTube content. You can also join our Discord community where we exchange cool ideas about the Forex trading, algo trading and stuff like this. The link is down below in the comments or in the video description, I guess. So anyway, if you have any questions, please put them in the comments. When I finish creating all of the content for you regarding building this app, I might do a short Q&A and I will just import comments from my videos.